So in our activity yesterday, or at least in class, we were working with parallel lines and an intersecting line. And we started talking in that activity about the intersecting line being called a transversal. So a transversal is a line that passes through two or more lines in the same plane at two or more distinct points. So even though the lines we were working with in class were parallel, the lines, as long as there's two or more, then a line that intersects two or more lines is going to be considered a transversal. So I've got several angles in this drawing. Notice that none of these lines look parallel, and that's okay. So let's talk about angle 1 and angle 12. Angle 1 is here. Angle 12 is here. So these two angles, the transversal for those two angles would be line L. I'll make it a big L. So this is the transversal for angle 1 and angle 12. Okay, then what about for angles 3 and angle 6? Well, angle 3 is here, angle 6 is here, and so these two angles share this transversal, which is J. So this is line J. Our next pair of angles are angle 7 and angle 15. So angle 7 is here, angle 15 is here, and they are both joined or connected by the transversal for line M. So line M. And then finally, angles 12 and 14. Here's angle 12, and here's angle 14. And so line K is the transversal for those angles there. So line K is the line that intersects these two lines and forms angle 12 and angle 14. So let's go back and revisit the parallel lines and the transversal. So here we have this transversal, and we are told that line L and M are parallel. Okay, and because they are parallel, then we're going to know some things about some angles. All right, so first of all, let's identify our two parallel lines. I'm going to highlight these in green. The two parallel lines are green. And we have a transversal. I'll make it orange. So I'm going to highlight the transversal with orange. Okay, so the transversal, intersecting the two lines are going to form 4 angles at each intersection. So let's label those points, or let's label the angles 1 through 8, and we'll start here. Let's label this one as 1, this angle is 2, this angle 3, this angle 4. I'll number this one 5, label this one 6, 7, and 8. Okay, so some of the things that we discovered with our activity is we discovered that certain angle measures, certain angles have the same measure, and then certain angles add to be 180 degrees. So I want to kind of make that kind of formal. So let's talk about vertical angles. Vertical angles and linear pairs we've talked about before. So let's talk about a pair of vertical angles. Angle 1 and angle 3 are vertical, and vertical angles are congruent. Now, here's something to remember. Congruent means same measure, and the symbol that we use is the equal to symbol with a little squiggly on top. So vertical angles, one pair is angle 1, and we'll say that it is congruent to angle 3. So that's one pair. We have another pair, angle 2 and angle 4. So angle 2 is congruent to angle 4. Angle 2 and angle 4 are vertical angles, so they are congruent. They have the same measure. Then let's move down to this intersection. Angle 5 is congruent to angle 7. And then also angle 6 and angle 8 are vertical angles. So they are also congruent. So angle 6 is congruent to angle 8. And so vertical angles are angles that are opposite each other at the intersection of two lines. Okay. All right. Then the next pair I want to talk about is a linear pair. And we've talked about linear pairs. Well, a linear pair are two angles that are adjacent that create a straight angle. So the linear pair, there are several in our diagram. So one would be angle 1 and angle 2. Angle 1 plus angle 2 equals 180 degrees. So angles that add to be 180 are called supplementary. And supplementary angles equal 180, means they add to equal 180. So angle 1, angle 2 are a linear pair. Angle 1 and angle 4. So angle 1 plus angle 4 is equal to 180. And we could also say angle 4 plus angle 3 and angle 3 plus angle 2. But I'm not going to list all of them. Let's go down here and pick a couple. So what about angle 5? Angle 5 plus angle 8 equals 180. And how about angle 6 plus angle 7? So linear pairs are two adjacent angles that form a straight angle. Straight angles are 180 degrees. So the next thing we talked about in our activity yesterday was this idea of a transversal is a line that intersects two parallel lines, two or more parallel lines. And I want to talk about this idea of alternate interior. And I'll begin by talking about interior. So this idea of interior is referring to in between two parallel lines. So anytime you see the word interior here and here, we're referring to the area that is between, or the angles that are between two parallel lines. So now let's talk, and then the other term would be exterior. And when we're talking about exterior, we're talking about outside of the parallel lines. So exterior would be outside of the parallel lines. Okay, so this is outside, and this is inside. So if it's outside, it's exterior. If it is inside, it is interior. If it is in between or inside the parallel lines, it would be considered interior. So now what we want to do is I want us to look at the relationship between the angles that are considered to be alternate interior angles. So alternate means opposite side of the transversal. So here we have a transversal. Here's our transversal. And the angles that are on opposite sides are going to be 2, 4, 5, 7, 8, 6, 3, and 1. But I want to focus on the ones that are on opposite sides and in between or inside the parallel lines. So now just focus on these 4 angles, angle 3, 4, 5, and 6, and which ones are alternating. Which ones are on opposite sides of the transversal? That would be angle 3, that would be angle 5. Angle 3 and angle 5 are on opposite sides. They are interior, and we just found out in our activity that those angles are congruent. So alternate interior angles, angle 3 is congruent to angle 5. And the other pair of alternate interior angles is angle 4 and angle 6. And they are congruent. So alternate interior angles, angle 4, angle 6, are congruent. So let's drop down and talk about the same side interior. So we're still talking about the 4 angles that are in between the parallel lines, but let's identify the angles that are on the same side of the transversal. So the same sides are angle 3 and angle 6, angle 4 and angle 5. Well, what did we decide, or what did we figure out about angles that are on the same side and interior? Well, we found that they added to be 180. They are supplementary. So what does that mean? That means that same side interior angles, such as angle 3 and angle 6, will add to be 180 degrees. Same thing with angle 4 and angle 5. Okay, so alternate interior angles are congruent, and same side interiors are supplementary. They add to be 180. All right, now let's focus on the angles that are outside the parallel lines on opposite sides of the transversal. So in my red area here, here, and here, this is the exterior of the parallel lines. So 2 and angle 8 are on opposite sides and are on the exterior. Angle 1 and angle 7. So what did we, alternate exterior angles are congruent. We discovered yesterday that these angles, alternate exterior, are congruent. So that means angle 2 is congruent to angle 8, and angle 1 is congruent to angle 7. And then same side exterior. So again, we have our transversal focusing on the angles on the same side of the transversal, but exterior would be angle 2 and angle 7. And what we realized is that the angles that are on the same side and exterior are going to be supplementary. They will always add to be 180. So that means angle 2 plus angle 7 equals 180, and that means that angle 1 and angle 8. Angle 1 plus angle 8 equals 180 degrees as well. So that kind of summarizes the things that we found when we did the activity in class. There's one other type of relationship that I want to emphasize, and that is corresponding. Angles that are corresponding are basically angles that are in the same position. So like angle 2, notice that angle 2 is on the left side of the transversal and it is sitting on top of the parallel line. So this angle and angle 6 are corresponding because angle 6 is formed with the transversal and it is sitting on top of the bottom parallel line. And we know that those angles are congruent. So corresponding angles, angle 2 is congruent to angle 6. Another pair of corresponding angles would be angle 1 and angle 5. Angle 1 and angle 5 are congruent. How about angle 3 and angle 7? And angle 4 and angle 8. And are there any others? No, I don't think so. But corresponding angles are congruent. Okay, so that's something to recall as well. So this just reinforces the things that we did in our activity in class. So let's look at another example. And so here I want us to, we're told that line M is parallel to line N. Oops, I need to pull that down, I'm sorry. But these little lines should be vertical lines instead of slanty. But anyway, so M and N are parallel, and the measure of angle 3, this angle right here, is 47 degrees. Okay, so let's identify the measure of all of the remaining angles. So we'll start with angle 1. What's the relationship between angle 3 and angle 1? Well, they are a linear pair, so the sum must be 180. So angle 1 would be 180 minus 47, which I'm pretty sure is 133. So angle 1 has a measure of 133 degrees, and the reason why is because angle 1 and angle 3 are a linear pair. Okay, and there's other reasons and other ways we could justify our answers. But that's angle 1. Now angle 2. Angle 2, you might say that angle 2 and angle 3 are vertical, so therefore angle 2 must be 47 degrees because vertical angles are congruent. So angle 2 and angle 3 are vertical. That's our justification. Angle 4, we know that this is, what did we say this was? This is 47, this is 133, and angle 4 would also be 133. And the justification can be one of a couple of things. You can say that angle 1 and angle 4 are vertical. You could also say that angle 3 and angle 4 are a linear pair. You could also say that angle 2 and angle 4 are a linear pair. So there's several ways to justify and give a reason why you know the angle measure is what it is. So what about angle 5? So here we have angle 5. Okay, angle 5 right here. And we've got to figure out what its measure is. So the measure of angle 5, we can determine a number of ways. We could look at it from comparing angle 5 with angle 3. Angle 5 and angle 3 are inside the parallel lines and they are on the same side. And therefore you know that they must equal 180 degrees when you add them together. So angle 5 will be 180 degrees minus 47, which again is 133 degrees. And so one justification could be that the angle 5 and angle 3 are same side interior angles. You could also say that angle 5, another justification could be that angle 5 and angle 4 are alternate interior angles, and alternate interior angles are congruent. All right, angle 6. Now we'll move on to angle 6. What do we know about angle 6? Well, angle 6, if angle 5 is 133, then angle 6 must be 47, because angle 5 and angle 6 are a linear pair. So angle 7 is 47 degrees, and it's because angle 6 and angle 5 are a linear pair. And linear pairs are supplementary, and that means they add to be 180 degrees. All right, so what about, if this is 47 degrees, now what is angle 7? Angle 7 must be 47 degrees, because angle 7 and angle 6 are vertical angles. So if angle 6 is 47, then angle 7 must be 47. And so our justification is that angle 7 and angle 6 are vertical. Now, that's just one way to justify it. You could also justify by saying that angle 7 and angle 5 are a linear pair. All right, and then finally, so if this is 47, finally let's talk about angle 8. And angle 8 must be 133 degrees. And one justification would be that angle 5 and angle 8 are vertical. So these two angles are vertical, which are congruent. You could talk about it in terms of angle 8 and angle 7 are a linear pair, as are angles 6 and 8.